Okay, so normal titrations. Normal titrations first. What you're going to have is you're going to have a conical flask, and let's say you've got some acid in here. Right, so let's just paint that red to make it an acid, and you're going to know, okay, so first of all it's the acid, and let's say you know the volume. How would you know the volume? Because you've used a pipette, right, to put it in there. So let's draw a little pipette here. Okay, you've used a pipette to put your acid in, so let's say that's 25 ml. And so you know the volume of your acid, and what you don't know is your concentration. That's what you don't know. Let's say with the whole normal titration is done in order to find the concentration of this acid. And let's, for argument's sake, let's say this acid is hydrochloric acid. Okay, so what you're going to do is you're going to get your burette out, so let's draw a little burette with a tap. So you're going to get your burette out, and what you're going to do is you're going to put a certain amount of alkali in there. So let's say alkali is in your burette, and let's say that is sodium hydroxide. And you're going to do, that is a known concentration. So you know the concentration of your alkali, and then you add your alkali to your acid, and eventually you get neutralization. Right, so we're going to repaint that green. So you get neutralization after a certain volume. Okay, so known volume at neutralization. Okay, so then you've got concentration equals moles over volume, and from that you can go through the calculation to find out this. All right, so you've referred to your balanced equation. So in this case we've got HCl plus NaOH goes to sodium chloride and water. Okay, that's our balanced equation. So what you know is that because you know the concentration and you know the volume of your alkali, you know the number of moles of alkali, and then if you know the number of moles of alkali, then you know the number of moles of hydrochloric acid when you get to neutralization. So now you know the number of moles of acid, and you already know the volume of the acid. So from concentration equals moles over volume, you work out the concentration of the acid, which is what you were after. Okay, so that is a normal titration, basic titration. And now we'll have a look at back titration. And a back titration is pretty much the same, except with one crucial difference. And the difference is you react some of the acid with something else. Something else first. All right, why do you do that? Well, your objective is different. So your objective in the normal titration was to find out the concentration of the hydrochloric acid. But with the back titration, you're going to know the concentration of your hydrochloric acid, and your objective is to find how many moles of something else, in our case it was calcium carbonate, wasn't it? So whereas in a normal titration you had a certain number of moles of acid and a certain number of moles of alkali, and you reacted those two together to get salt and water, which were neutral, and for the acid you knew you didn't know the concentration, but you did know the volume because you used your pipette. And for the alkali you knew both the concentration and the volume. In this case, in a back titration, what we do is we say, well, okay, we're going to know the concentration. Alright, we're going to know the concentration and the volume of the acid. We're going to know the concentration and the volume of the alkali. So that's good, but what we're going to do is we're going to react some of this acid first with the tablet, or at least the active ingredient in the tablet. So that's what we're going to do. So what you do is you do your titration to work out the moles that are left. You do the titration to work out the moles that are left of the acid. Okay, so that's from your titration. All right, now the moles of acid that you started with, you get just from the data that's given in your equation and the data that's in your question plus concentration equals moles over volume, and then you get the total. So then, let's just change colour. Then this bit, the amount of acid that reacted, is just one take the other. It's just a difference between what you started with minus what you found from your titration that was left over, the acid that was left over. So that's the difference. But that's the difference in moles of acid that reacted with the calcium carbonate. So then you need to just refer to your balanced equation. You need to refer to your balanced equation to get the molar ratio. Use the molar ratio, and in this case we were using a 1 to 2 molar ratio, and that gives you your moles of calcium carbonate. And from your moles of calcium carbonate you get your mass of calcium carbonate using your mass equals moles, mass equals moles times MR equation, and that's what the question was asking you for. So I don't know if that's helped you, hopefully it has. In any case, I'll see you on Thursday.